This is, as you know, a human among humans, and we have an astro for your delight. After the 4th of July, we have an astrophysicist with us who is going to help us explore how the universe and our knowledge of it may be able to help us, give us a vision that will carry us through all the challenging times. And I know her first name. It's Kathy, or Kathy. Yes, and your last name?
Flanagan.
Kathy, yes, I remember now. My name is your host. I'm your host, Michael Koran, and we're going to now explore the universe and what it can do for us.
There you go.
So, you tell us now again. You just told me before the show started. You got into science in order to impress your older brother.
I did. I was just the little sister.
It's good to have noble reasons for this will free all of us. We can have the most mundane reasons to do what is spectacular.
I wanted my brother to take me seriously, and I was just his little sister. I might have been wasting his time, but when we talked science, we talked. And that's true to this day. We still talk science.
And he's a physicist too.
He's a physicist too. One of the best I know.
And but going into astrophysics is a particular choice of yours.
Yes.
And because?
Well, the truth is, almost everybody is entranced by the universe, looking out at the night sky and wondering if someone's looking back, wondering what's out there. Why is the twinkling? Can I see a planet? What's on the moon? We all wonder that. That natural attraction, I think, is for everyone, and it carried over all my life.
Yours is sounds more healthy. I was interested in it in order to learn how to survive. As I was telling you before the show, when I heard about black holes, I said, "Oh, that's what I've been afraid of inside me."
Ah.
And then I realized, tell me if I could get this wrong, but it's helped me so much. The black holes have light coming out of the sides. Is that true?
No,
Oh.
not really. That's why they're black.
Nothing comes out?
The light doesn't come out. What happens is the matter goes in, and because of the gravity.
Yes.
But a lot of time, as the matter is going in, it's very hot and it radiates light. Just
That's what I
before it gets
thought.
sucked up.
Yes, that's what I
Yeah.
thought.
Yeah.
And so I could feel inside darkness or spaciousness and light. And so all those songs, "Hello Darkness, my old friend, you've come to dwell with me again." Or there's a story of a man who lost his leg, and he's put in a rehab. And the psychologist, Naomi Remen, is caring for him, and he's very depressed for 2 years, understandably. And then he decides the only way to get out of my depression is to go out of my room and see if I can cheer people up. And maybe if I cheer them up, I can be cheered up. Again, maybe not the noblest of reasons, but life is a true reason for him. He goes into a room where there's a woman who's had a mastectomy. And there's music on the radio, she's not even listening to it. She's so sad. And he thinks one of the only ways he could cheer her up is he takes off his artificial leg and starts dancing to the music on one leg. And she, after she hears this pop, dancing on one leg, opens her tearful eyes and says, "Well, if you can dance, I can sing. And she starts singing along with the music as he's dancing. After this event, he goes visits his therapist. And she says, I'd like to show you what you drew 2 years ago when you came in. Oh, good. We have just at the great point of the story, we have, come sit behind us, Sarah Brett. So the therapist takes out a drawing of a vase with a big crack in it. And he had drawn this 2 years ago when she said, please draw me how you're feeling about your body. And he sees the crack and takes a yellow crayon and draws all the crayon yellow over the crack. And his therapist, Naomi Remden, says, why did you do that? And he says, through the crack, the light comes through.
Oh.
And that's what helped me with when I discovered about black holes, and it's what you just said, some of the energy coming in can't quite get in, as I understood it, and bounces back as light.
It radiates as it's going down.
Yes, into the universe.
Mm-hmm.
And I discovered inside what I've been so afraid of. The darkness. I always thought I had to keep talking in order to hide from my darkness and it's really scary spaciousness in some sense. And then I thought, as I heard about black holes and the light, oh my, I've got a black hole in me too, like the universe. Like almost every galaxy I know has a black hole that keeps it together.
Mm-hmm.
And it's a mystery, as you were saying before him, but there's a radiating light from it. And if I'm not afraid of it, there's great peace there for me. So that's how astrophysics began to help me.
Good. I'm really glad.
So this is behind us, is the wonderful Sarah Brett, who is going to, if we have any problems answering the relationship between the universe and our personal lives, if she feels like it, will answer our questions. Thank you, Sarah.
You're welcome.
Mm-hmm. So, you're taking up physics or science because we're going through Kathy Flanagan's life. She wasn't aware that this is like the old show, This Is Your Life. Right? We're going to have your 4 children are coming through that door in another
My secret's coming out.
second half of the show. So now you made a decision somewhere along this journey to go into astrophysics.
I did.
Because?
Well, it was just a specialty that I really thought I'd like. I knew I wanted to do physics like my brother. And I really liked science of the universe. I remember walking through a building at MIT one day, and I decided I would check in every single door and ask what they were doing for research and find a thesis topic. First door I came to, I spoke to the student there and asked him what he was doing. He said, you want to speak to our graduate student? I said, yeah, okay. Spoke to him. He said, you want to speak to our professor? I spoke to him. He said, do you know any astrophysics? No. Any computer programming? No. Do you remember Bragg's law? No.
What is Bragg's law?
It's how X-rays bounce off crystals.
Wow, it's exciting.
And he said, you have no bad habits. Would you like to work for us?
Would you like to what?
Would you like to work for us and join our group? And that's how I wound up in space science. It was the first door I opened, and it was a great door. I never had to go to door number 2.
Wow, the price is right.
The price is right. And the fact is, if you're not having fun, go ahead to door number 2. There's always another door. But door number 1 turned out to be pretty wonderful.
You've been having fun.
I've been having so much
I'm
fun.
gonna cry. So what was your thesis on?
So my thesis at MIT, well, I had an undergraduate thesis when I was 22.
Which was on?
Which was on a 7-wire imaging proportional counter, an instrument to look at the sky in X-rays. And it's used on multiple missions. And later in life, I came back for my PhD, and I used one of the instruments as part of the thesis. That actually the one that I worked on was part of the detection, and another instrument that was going on a new mission that I was working on. So it was the Chandra X-ray Observatory. I had done all my graduate work on that, and I looked at a supernova remnant and did a particular research project with including both my hardware and my astronomy.
And what did you discover about the supernova?
Well, I discovered it takes about 10,000 years before they settle down and come to equilibrium, at least that long. They're very slow, and they're very beautiful.
And their supernova, if I remember, is an explosion of a star out into the...
Yes, you're right. It is.
When it's dying, really.
When it's dying. And my motto is, live fast, die young, leave a beautiful corpse. That's what a supernova remnant is. It's a beautiful corpse.
That expands them.
Yes. It goes out into it's a shell that goes outward with a blast wave. It collects all this matter that's in the surrounding environment and lights it up to X-ray temperatures, and it glows. And you can take a look. I looked at one of them, and I discovered by eye, with an instrument I worked on, it's got oxygen, nitrogen, magnesium, silicon. I could see everything. I could see that it was expanding. I could see how fast it was expanding, what shape it had. It was great. Just like that.
So this, I believe in a life after this one. Mm-hmm. And that's the best analogy I've ever heard. So I can die and then explode.
Hey, we're actually in luck. The fact that we have oxygen means some star blew up in our environment. We wouldn't get the oxygen otherwise.
We got the oxygen from an exploding supernova. Yeah. So the deaths have given us life.
Exactly right.
And it doesn't have to be a supernova, any star.
It has to be massive enough to produce enough oxygen to get out to us. So it's probably a massive star somewhere in our environment. And because of it, take a deep breath, we get some oxygen.
Wow.
And if we're wearing gold rings, explosion of a supernova, very likely, right? All around us is evidence of stars living and dying.
It is amazing the education you have, because you see things with so much possibility.
Oh,
yes, I
can feel
it. Because many scientists are not, well, we won't go to other people though, but you have this great humanistic optimism. Now, I can't imagine these amazing entities not having some kind... It seems to me supernova would have super awareness. They're not just... it's too reductionist to think that they're not in some way probably more aware than we are.
You mean on Earth, or do you mean?
And both the Earth and there's a theory called the Gaia principle. You're probably familiar with it. The Earth is alive. And we're part of the life of the Earth. But it seems to me the cosmos is alive.
Yeah. It's interesting. It definitely evolves. That's for sure. And to be honest with you, we mentioned this earlier. I think the next great astrophysics frontier is going to be looking to see if there's life elsewhere in the universe. That's very, very likely.
Are we talking Mars? Because I feel like
beyond
that's
Mars.
Oh,
so Mars, we're definitely going to Mars,
yeah.
And they're in our solar system. They're really good candidates, but we're looking at the possibility of life on planets around other stars. Wow. We now know there are many, 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 many planets, and a big fraction of them are in the zone that's probably habitable. And where life on Earth, we know where life can happen, it does.
Wow.
Wow.
So there's a, and we're ready to look for it. I mean, definitely, definitely there. It's going to be an exciting future, that's for sure.
Oh my, you get, I mean, this it grounds my hope in life after this one even more. It's not even a belief. It seems a certainty to me. Because I'm ancient in years now. I'm 81, so thoughts of death happen from time to time.
But time, space, reality. What's 81? It's like,
Oh yeah,
it's just a snap of a finger.
it is actually. It is actually.
I'm certain about leaving this physical body and just going into. I'm 100% certain. Same with Michael in that.
And I experience it daily. You know, I mean, most vividly in my divorce, but that life seems to be like sleeping, a death and rebirth daily. Who am I today? I don't know. And that seems very comforting also, that whatever's happening, just like the supernova, there'll be, even though the death is contracting, right?
Right.
And then
Right.
yeah.
Yep.
Hope for all of us, Tyrone. We have a wonderful audience member who can participate when he is moved to.
I'll be a good
Come up here behind, stand behind Sarah.
I'll be a good listener.
No, they have to hear you. You have to come.
Right here.
Yeah. And you can take your mask off, Tyrone, if you want to. Yeah, you can take your mask off. Yes.
It's a little high.
Oh, that's good. Just.
And you were going to say?
Thanks for having me on the show.
It's deep. Tyrone gets to the deep. It seems basic, but it's deep.
He was asking you a lot of questions.
Oh,
and
yeah.
he figured it out.
Yes. I would like to mention, if it's okay,
About
last
the
night
web.
Tyrone and I were talking, and he understood every single aspect of how the next great astrophysics mission was designed. And so, if it's okay, can I
Yes, for sure.
All right.
Yeah.
One of the missions that I worked on, and I'm very proud, is the James Webb Space Telescope. And it was launched recently. It's the biggest astrophysics mission in the history of NASA. Has 3 space agencies that worked on it together. The NASA, the European Space Agency, the Canadian Space Agency. Amazing folks. Worked on it for decades. It launched just before Christmas. And on Tuesday at 10:30 in the morning, the first science observations are going to be revealed for the public to view. And I anticipate it's going to actually blow the lid off science. This is going to be it's going to be as good as Hubble for imaging. In fact, where it overlaps Hubble, it's better. It's going to be unbelievable. And my favorite thing that it was designed to do was to look at the first galaxies that ever formed in the universe right after the Big Bang. That's its capability. It's called the first light machine.
The first flight machine?
First light.
Light?
First light machine.
Oh, my.
I know, right? So get ready. Tuesday, 10:30.
It makes me cry, actually. So, one scientist, I think it might have been Eddington, said the universe is stranger than we can even imagine. It is so rich. And so, from what we've been talking about here, comforting that whatever dies gets reborn in an awesome way and nourishing us.
Yeah.
If those stars that turned into supernovas did not, we wouldn't have oxygen to breathe.
That's right, the
or
conditions
gold
for life.
to
Right.
get married with.
We'd make do.
But I mean, plants, food, everything.
Exactly, the whole thing.
That all rebirthing with seasons. It is amazing.
That's right.
Now, how come it's like this, Kathy?
How come it's like?
I mean, did someone design it, or is it improv? I like improv. Or now, I've done some improv teaching. In some ways, your class was improv,
Right.
but the rules for improvisation, they're rigid rules that you can then freely improvise. For example, in improv, if I say, "Wow, a cat just jumped up on our desk here," you have to say, you can't say, "No, it didn't." You're not allowed to do that in improv. You have to say, "Oh, I hope its whiskers don't, it's shedding a little bit. I hope." So you have to go with what's there. So improv has its own rules, and within the structures, like all the, whether it's marriage or this television show, did we know what we talk about? No. Did we know who would be here? No, but once I knew you were coming, I knew I wanted to do astrophysics and its relationship to how we live our lives. Now, has it helped you live in some of the challenges of life?
Yes, I do think so. I actually think that being a scientist requires a lot of discipline and a lot of hard work and an eyes on the prize and a big picture perspective, which I think helps in life. But I also think, truthfully, the end game, the goal, is just so inspiring that it's worth it. And I actually think, if you don't mind me
And by
saying
the end game, you mean
learning.
just learning.
Just learning.
Why is that an end game, not just happening?
Well, it's really a process,
Oh,
right? Because the truth is, when scientists find out they're wrong, that's even better, because that means there's still more to learn. So it's not a problem. The more we see, the more we realize, oh, we don't understand.
I have
There's
a poem,
mystery here.
saying, look, the more mistakes I make, the more I grow. And I've got so many mistakes.
I do find mistakes very educational,
Oh
personally.
boy! Thank God for mistakes. But go on. You were saying
Yeah.
but the specific discoveries are not analogies for helping you live your life.
No, and partly because they're not going to stop. I don't know what they're going to be. We designed, for example, let's talk about James Webb. It had 4 great science themes that it was going to look at. I can guarantee you that's going to be in the rear view mirror in no time. What it will find out is going to be vastly bigger.
So the same thing I was saying about improv. You have a structure and then...
Yes, and you go. And if I have a personal opinion that everyone is actually born a scientist. When you see a 6-month-old put its foot in its mouth...
Yes, it's experimenting.
Exactly.
Yeah.
That day an experimentalist is born. We are all scientists. We are all born to be scientists. Yep.
I'm just getting down to earth enough to begin to be a scientist. I was very much into my head. But now finally, with the help of my friends, I had a poem song. To get out of our minds, let's get into our heads, into our heads, into our heads. To get out of our minds, let's get into our heads. That's how we get ahead. So, you graduated MIT.
Yep.
And then?
Then I did the obvious. I joined the Peace Corps.
Oh.
After my undergraduate years.
And taught science.
And taught science,
How
taught
was-
math and physics.
Where was this?
It was called Zaire, which was the former Belgian Congo and is now Democratic Republic of Congo.
And how was that?
It was fantastic.
Oh, you loved it?
Yeah, I did love it. Great students, great students. Lack of, we didn't have electricity, we didn't have running water and so forth, so I didn't have too many experimental things I could use to teach with. Guitar string maybe and a few other things. I have to admit, on the second year we were there, we had a war. So I taught very rapidly, breaking the sound barrier because there were jets coming over the town, and a few little tricks on the way out.
Wow.
But yeah. But it was really wonderful. And the thing I learned that I think I shared with you, true poverty is a lack of dreams. That the best thing I could give my students,
Wow. And you did.
I did, and they did for me too.
They did for you in what way?
Yeah, because I came back sort of really, you come with a structure that you think you understand and the world is a certain way, and if you're receptive to it, you learn, whoa, it's so much bigger than you thought, and you can think more flexibly and you think differently, and you even see your own culture with different eyes.
Yes,
Right?
yes. Oh, yes.
Yeah, so they gave a lot to me. My students and the people of Zaire gave me a lot.
Yum. And then you
Yeah.
came back
I
here.
came back here and eventually went to graduate school, got my PhD, and started my professional career.
And where did you start that?
So I got my PhD from MIT, and then I went.
And what was your thesis on?
It was a physics thesis on the plasma diagnostics from that supernova remnant,
Oh,
using the
my.
instrument that I'd worked on, and a component
So
of.
PhDs really bring new knowledge.
They do.
They're
It's
not
original
just-
research.
They're original. Wow.
Yeah, and they're you become very expert in some small niche, right?
Yes.
But you do get the phone calls every now and then. How can I fix this? What did you find out? You know, it's a little helpful, but it also teaches you to think with an impossible problem how to approach it. So I find that physicists are simple thinkers. If we were to design a tree, it would have a root, it would have, a branch, it would have a leaf. We're done. So you don't really want us to build the final model. Let's just put it that way.
Got it.
But that's how we approach most things. We simplify them and then think about it, and it helps us a great deal.
And then you went.
Yeah. Then first I had a job at Harvard-Smithsonian Center for Astrophysics.
Oh, right here?
Right here in Cambridge. And I worked on instruments for the Chandra X-ray Observatory, which is operated here in Cambridge. Then I went to MIT.
The observatory is at.
Yeah, it's a satellite observatory, a NASA observatory, so it's orbiting. But the operations center, last I checked, was in Cambridge.
Oh, my.
Yeah. And
So do you often probably use a telescope to look at the sky?
oh yeah, well, scientists do. It's very competitive. I'm not really a good astronomer compared to most of the others, but yes, that's how the best way for us to look at the sky, and the only way in X-rays, is with a satellite, because the X-rays don't get to the ground.
Oh, so you don't use a telescope like?
It is a telescope,
Oh, it
but
is?
it's launched on a platform above the atmosphere.
Oh, and how do you physically look?
We orient the telescope to look at the object.
And where are you located when you do that?
So if it's Chandra, it would be in Cambridge. They would send the commands up to Chandra. They would have it look at the target. They would gather the data and send it back down to the Earth and send it to the observer to actually
Is this open to
analyze.
the public?
It is. Everybody in the world.
Sarah.
Yep.
Tyrone.
Yes, for NASA astrophysics missions, for Chandra, for example, for Hubble, and for James Webb, for sure, anybody in the world can apply for observing time. It's very competitive, very difficult, but
Competitive mean we just have to wait our turn. We don't have-
No. You
We
have
have
to
to do
put in a
stuff?
proposal and write what you're going to do, and you have to be selected as
Oh, I
the
can't
best.
just say because I want to see.
No.
Oh.
No, you have to say, this is what I'm going to do, and this is the question I'll be able to answer if
Oh.
I do it. And then it gets selected by a peer review panel. They're always good proposals.
I'm counting on you,
Amazing.
Tyrone. Is beyond me.
Yeah, but eventually the data becomes public for anyone to use. So there's many years of Chandra data. You can go in right now. You can find it online. You can actually start publishing
It's just
anybody.
a great feel. I can just, more than even the things you're saying, your feel for the universe is a gift.
And this is a democratic gift to the world in some ways, right? Knowledge, anybody can access this. Anybody can be the originator of new ideas with this. It's just a wonderful thing. And that's why I think more and more of our missions are now multi-countries, right? Like Canada and Europe and US for the next one, for James Webb. So yeah, it's open to the public, and the data will be publicly accessible eventually.
And you started teaching.
I didn't teach actually. I did, after I worked on instruments at Harvard Smithsonian, I then went to MIT and worked on instruments, and eventually,
And working on instruments
meaning helping to design and test and prepare flight instruments for NASA.
so you're like an engineer.
No, I'm a physicist. An engineer would cringe.
Oh, so what do you mean by you?
I'm the type of person who would use aluminum foil to fix something. Not an engineer.
So what does it mean to work on instruments?
Well, because, for example, one of the instruments I worked on at MIT is what we call a spectrometer. So it takes the light and it tells you exactly what elements are in it and what temperature those elements are and so forth. However, it was so good that we actually had to go and test the properties of gold in order to be able to accurately use it, because it was so good. It was much better than any published information on the materials.
I don't quite understand
So what would happen is gold, we would make gold gratings, but they can leave a little imprint on, a little artifact in the data that you have to understand what the gold properties are to be able to understand what the light that came through it, what was the light from the target, and what was any impact from the gold. So you had to know if there were edges and features that the gold would introduce. Nobody knew them well enough. We had to go test that material. We had to model it. We had to understand
So
it.
you draw, or how does it literally work with you and building the instrument? What is your contribution?
So for multiple instruments, many of my contributions involved what we call calibration. So it's one thing to have, for example, let's say a detector that says, ooh, I see something. But it's different to know exactly how bright it was, to know exactly what kind of light it was, to know exactly where it was on that field. That's where you calibrate your instrument. So you have to understand it very thoroughly.
And you tell the engineer what to do.
To some degree, yes. We make a design. We usually have scientists make the instruments from scratch. Depending on what the instrument is, those can't be purchased. They have to be made. They have to be understood to a T. The absolute physics has to be understood, because we're now in a domain well beyond anything published or seen on Earth, right? Again and again and again. So once you understand it, and the engineers have constructed the actual instrument out of the parts that are made and so forth, and it's launched, when the data comes down, if you don't have the calibration, if you don't have the understanding, you still don't know what you're looking at.
Oh my!
And with NASA instruments, when you're out there, boy, it's cutting edge. It's always cutting edge. So you have to.
And so you were working for NASA.
I worked for MIT, and I worked for Harvard Smithsonian on NASA projects.
On NASA project.
So, but I wasn't a NASA civil servant. Then I got a call, and I went to Baltimore. That was my final professional step, was to move into management, actually, and I worked on James Webb. I was the mission head for James Webb, in charge of developing the Science and Operations Center, how we would command it, how we would arrange to get the science to the proposer, how we would run the peer review process, how we would do outreach, for example, to get that process started when the mission was finally ready. And after a few years of that, I'm proud to say someone else has taken it over and done a brilliant job. And I moved on to as a deputy director and director of my institution and other positions.
Wow!
Yeah. So that's why I'm kind of excited, and that's why I'm not looking too bedraggled, because I gave the hard job to someone else.
Oh my!
And you were in Baltimore for how long?
I was in Baltimore for 8 years.
Oh, wow.
8 years, yeah. And I'm going back next week for the big reveal on Tuesday, 10:30.
Oh, you're going to be there?
I'll be there, yeah.
Oh,
Fingers crossed, hope it looks good, but I'm pretty sure it will be.
And if we want to watch live,
So I would go to the NASA website, and I'm sure there's a link to be able to watch, and I think you should watch live because most of the world will be watching. I think it's going to be a big deal. Just to be
10:30
true.
a.m.
10:30
Eastern
a.m.
Standard
Tuesday.
Time.
Yep. That's when it happens.
So we'll see something like the first galaxies forming.
I think, this is my guess, I think they will try to look at very, very early galaxies, the first ones forming. Don't know. I think they will try to look at something in the solar system, so we'll maybe see one of our outer planets. I'm hoping. Maybe even the moon of an outer planet. I think that would be great. I'm guessing there are everywhere in the universe where stars form and planets form, it's dusty and murky and complicated and you can't peer through the veil of it. I think what's going to infrared, this is an infrared observatory, infrared light gets through.
Wow.
And so we will be able to peer into spectacularly beautiful star-forming regions and maybe even see little protoplanetary objects, things that might become planets. I think that's possible, but I'm just guessing because I didn't arrange the palette. I don't know what they're going to do. I don't know what they're going to reveal, but I'm pretty sure it's going to be spectacular. And I'm pretty sure we will have a lot to say about spectroscopy, which tells us what elements are there and so forth. My husband used to say it puts the fizz in astrophysics. That's what I'm looking for.
He was an astrophysicist.
He was too.
Oh my Lord, what
Stephen
a marriage.
Murray. Yeah.
So you would talk about this at dinner?
We would.
Wow.
Of course. And occasionally when we were in different institutions, if it was proposal time, I would come home and say, I can't talk about optics for a while. And he'd go, oh no. He'd know that my institution was about to put a competing proposal in. So we would have, marital agreements that there are some things we can't talk about. We understood.
And the children became...
Japanese scholars and brain scientists and American history experts, but not physicists.
I understand. So what we're seeing is the light from these early galaxies traveling 13 billion years?
Yes, it's going to be so great. Because if you look at the most distant galaxy you can see, it takes 13 billion years or more for the light to get there. So whatever you see when it gets here, that's what it looked like then, right after the
Let's
Big
see if
Bang.
I can wrap my head around it. Maybe Tyrone and Sarah can help. So it happened 13 billion years ago.
More.
More than 13, but not 40. We're only 13.8 billion years old.
Yeah, it's a quibble about that last digit, but yeah, somewhere around there.
Yes. Yeah, well, who cares? It's 7, yes. Well, we've got a lot of years, Tyrone. We've been around a long time. And we're made out of that stuff.
Yeah, there you go.
So let's see if I can get around all of this, one at a time. This happens 13 billion billion years ago, 13 plus billion. And light from it travels. There wasn't such a big universe then, was there?
No, there wasn't, actually.
It was a little universe.
Yeah.
A little friendly little universe.
Right. In fact, it had to get kind of far enough along for the light even to be able to be released so that we can see it.
So this light is expanding with the universe. And while this is happening, or 13 billion years later, the Earth is about 4 billion years old, right?
Right.
So maybe 9 billion years after, the Earth begins to form in this expanding
You're smart.
universe.
Yeah.
But in the expanding, we're not just expanding, we're getting the light from the earliest galaxies also are coming to us. I think I have that.
Yes,
right.
you're right.
So and they might not not be there anymore.
It's true. It's true. Or they might look like our galaxy now.
Oh my.
I won't know for another 13 billion years.
But they might be smarter than us. They've been
I hope
around.
so.
They've been around much longer.
Oh, I don't know how old our galaxy is, but
Oh, how old are
Yeah.
you? Oh, our
Yeah.
Earth is 4 billion
our
years
Earth
old.
is 4 billion. Yeah.
Oh yes, that is. I don't know that either.
So, but I'm interested in that because if I get to see a galaxy right after the Big Bang, then I can surmise that maybe in our neighborhood we looked similar at that time. Maybe that's what.
13 billion years ago, we might have looked like that.
That's why it's interesting to me. And what it's going to tell me is not only what galaxies looked like 13 billion years ago, but what they looked like 10 billion and 5 and 2 and now, and how they changed over time. I think galaxies may have gone from blobs to beautiful spirals by interacting. But we'll find out. James Webb will tell us that. We will see
Wow.
that.
Well, this is going to be big for a lot of global warming information potentially.
So I'm not totally sure about that because this one is going to look outward. But I will tell you that NASA missions also have inward looking, earth science missions that actually really study things like, how do the polar ice caps change and things like that.
And we use the word galaxy, but a galaxy is, if I remember correctly, 1 billion
Yeah,
stars.
it's a lot of stars.
That's 1 billion suns.
Yep. And a lot of potential planets are on them, I might add. Just
What's
saying.
going
I
on?
know.
What is going on? What did and all of this comes from a still point,
Oh, that's right.
which people call the
You are
big,
so smart.
which
Yes.
people call the Big Bang, right?
Yes.
But that is when we really slow that down, and even the explosion itself, but before the explosion, it's just a point, right? So out of that, this is hard to believe, this is more miraculous than any miracle. Out of that really pinpoint, really, right?
Right.
Out of that pinpoint
I think.
comes the universe.
Yeah. But to be honest with you, I'm a little over my head with this.
Yes, but
Okay.
I think
Yeah.
that's pretty much the consensus.
Yeah.
It's, geez, what do you make of that, Tyrone?
It's kind of unbelievable, all of it.
That's an interesting word, unbelievable,
God,
too.
just the
Yeah.
scale and everything.
And we're learning a lot.
Like 13 billion years for something at the speed of light to get to
Yeah.
us. Like
That's
that's pretty far away.
yeah.
And it was made that way. It was made so that 13 billion years after, some galaxy could go back and see it.
Well, there you go. That's interesting. Maybe they're looking at us now.
Oh, I'm sure.
Someone said that with the COVID lockdown, someone's looking into their this tiny little glass and just seeing all these little tiny little ants just hang out in their houses, watching.
But this is very hopeful.
Yeah.
That the death of stars brings so much life,
Mm.
and that it's all connected.
Oh, it is for sure.
It's one
It is
big
for sure.
web.
Yeah.
The universe is a web.
Yep.
So our web is just a beginning to. So how come it's, with all this beauty, there's so much chaos in the world? Now, did it come from chaos? Was it, I think you were mentioning before the show, it was dust. These galaxies were dust before they turned into stars.
Yes, that's true. It's what we call a dusty environment, and
There's hope. to respect that and honor that, my apartment, as Sarah Brett knows, has more dust per cubic. I am just doing it to be with the galaxy.
In solidarity with James Webb.
Yes, to be this creative dust. It will.
It'll form into something.
Yes, thank you, Tyrone. Tyrone, you're my kind
Marvelous.
of man, Tyrone.
So there's a cute picture of a dust bunny, a big glob of dust, and someone holding a carrot up to it.
Oh
And
my.
underneath it says dust bunny. I love that.
So, but these galaxies, these billion suns, as I'm even saying it, is, do you ever get just awed by it?
Oh gosh, every day. Every day. And I feel inadequate constantly.
And yet, there's a wonderful poem by Emily Dickinson. It goes something like, "What I consider," won't do it in poetry form, but when I consider the universe and how vast it is, I realize I can think about it and still have room in my mind to wonder what I'm going to have for lunch. Our minds are big enough, apparently, yours is at least, Tyrone's and Sarah's have questions about mine, but your minds can take this in. We are made
Yeah.
to understand this. So I don't know about a God, but whatever is behind this is beyond what we used to think about God. Way beyond. However, it's just more amazing than could be thought. As one scientist said, the universe is more than we can even imagine.
Yeah, it's true.
And we're made to understand that. What does that mean, Tyrone?
I don't know.
I knew Tyrone would get to the heart of it. It's that, another Emily Dickinson poem. Wonder is not precisely knowing. And not precisely knowing not. That's it we have here, Kathy.
Yeah, it's true.
But it is leaving out, formal religions. It is, beyond awe. We can just rest in that wonder and know it's so life-giving.
I think I told you one motto that matters to me, and that I think is applying: without vision, the people perish. We are meant to question things. We are meant to learn.
And meant to have the vision.
Yes, we are. It feeds us.
And this is unending. Once this telescope is seeing things, there'll be more and more and more things we didn't dream of, I guess.
Yeah.
We might see things we didn't dream of Tuesday morning.
Oh, I can guarantee that. I mean, I believe that. Well, I don't know if it'll be Tuesday morning, but it might be. But we will definitely, within a few years, be going, whoa.
We might see a telescope looking at us.
Whoa. I don't think we will do it with this one, but I think we might do it with the next one. There's more on the horizon.
But I'm not, we are, I don't think you knew this, I said it before the show. We sent I think Carl Sagan was part of this, a space capsule out into the universe with maybe a little Bach, maybe a Beatles, a little Shakespeare, and we come in peace, which is not. And pictures of a man, sketch pictures. So I don't know what it would be like. People claim, and this is beyond your expertise, that extraterrestrials were here. Even the Bible, that there's passages in the early Genesis the sons of Elohim made love to the daughters of men, chose them as wives. And they were called, in Hebrew, Nephilim, fallen ones. So it seems that in the early traditions all over, there were visitors from beyond that were communicating with human beings. That might be wild if we discovered that. Maybe frightening, maybe helpful. Some might be kind, I hope. I mean, the religious tradition says there are kind ones. Jesus, Buddha, the angel Gabriel, and so on. Well, we have 6.5 more minutes. Any questions for Kathy?
I have a question about your colleagues and people in the astrophysics field. What are their, what is their faith like? Because we've have been doing a parallel between that.
So, to be frank, we don't really discuss that per se, but I was mentioning before the show that there are some parallels even in the professional endeavor of science. And I used as an example the discovery of the gravitational wave. We had the best scientists in the world working on an observatory called LIGO. And it was decade after decade after decade to look for a gravitational wave which was hypothesized to be there from general relativity but had never been detected. Extremely hard problem to solve. We call these scientists, my brother's nickname for them is the physicist's physicist. That hard, right? And decade after decade after decade, people in their 80s still doing it. And sure enough, September 2015, we discovered one. Finally. And I thought about this in parallel to a Jesuit priest I knew who was a physicist, and he's Catholic. And I realized the belief, the absolute commitment was very similar, both for religion and for science in that sense.
Yeah, well,
Right?
explain that a little more.
Well, in a belief system of religion, right, that's, you understand that commonly well understood.
You mean I believe that there's a life after this one, and that
For example, yes.
there's a caring
Yes.
God who created the Big Bang and is
Yeah.
going to take care of Tyrone and me and
Right.
you and
And your life is
Sarah.
structured with that belief. There are
Yes.
choices you make
yes,
that
even
depend
when
on
I'm
that.
lost. Yes.
But here are scientists who are spending the rest of their, not only
Also
their careers,
believing
but their lives, believing
that they're going to
there
find
is a gravitational wave,
Yes.
and I will invest my entire life
Whoa.
doing it.
Whoa,
So
and I might not live to see
Right?
it.
And I may not live to see it, but I will devote my life to it. And when I realized those two things, I think those instincts and those desires and those commitments are very similar.
Wow.
But they are not the same, but they are very similar. And one of the individuals who helped, Ray Wise, right? One of the individuals who helped is here in Cambridge. He was over 80 when he won the Nobel Prize.
Wow.
So I'm glad.
Hope for the over 80. Yes.
The physicist, yes. And I'm so glad.
And I have a friend who went to Line 3 to protest the Line 3 pipeline from Canada through Native American land. Unsuccessful. But it could be the same thing. Like they asked Frederick Douglass, the freed slave, what to do to make this a better world. And he said, agitate, agitate, agitate. You might not see the end, like Martin Luther King and all, Emma Goldman, all these wonderful people Dorothy Day, who worked hard to make a better world. And like the scientists, they can make particular advances, but it's not here yet. But that won't stop people from agitating, like like your scientists looking for the gravity wave.
Right.
And we will succeed like the gravity wave. You heard it here.
And you know, there's one other thing that as I retire, that I think about, because it's about the future, right? Wise men plant trees in whose shade they will never sit. The next generation is going to carry it forward, and I may not be alive for it, but I can certainly invest in what the future is going to bring. And that's the appropriate place for me.
Yeah, and we might, who knows, we might, like supernovas, die and come back.
There you
Like
go.
the Buddhists say, we do not know, except Tyrone might tell us. we only have a minute and 45 seconds. So maybe, Tyrone, any questions?
No, I'm just happily listening and listening in awe.
Me too. Sarah, Brett, any questions?
I am blown away. I'm going to probably go back and listen to this show over and over again and even just think about the numbers, because I think about as I get older and all those small scale history dates I learned about when I was a kid 200 years ago. That was so long ago.
Right.
And then you get closer and closer. You get older and older and you're like, 200 years ago wasn't that long ago. And now I'm thinking 13.8 billion years ago. You know? So it is fascinating. So just a whole new perspective.
Yeah. Well, I gotta say, it's a great time to be alive, and we got unbelievable things ahead of us.
Whoa!
It's true.
Take that, front page news. Take that. There's a poem I love. Robert Frost calls it Bids Pretty Fair. The play seems out for an infinite run. Don't mind a little thing like the actors fighting. The only thing I worry about is the sun. We'll be all right if nothing goes wrong with the lighting. Thank you.